I think there's three main kinds of questions I need to cover. I think we'll get started with just a straightforward one. Who knows what ones I've done. Did I do 1/4 x squared take away 1/2 log x? Do you recognise that one? So y equals 1/4 x squared, take away 1/2 log x, and we're going to evaluate it between 1 and 2.
We did do that one.
Okay, so no point in doing that one. I remember the last one we did was that really pretty one that ended up being 1/x. Okay, so I'm finished doing those kinds of questions. Let's show you an arc length question where the information kind of looks like it's missing something. So we have a function 1/2 x squared, and it's going to go from the point 2, 2, and it's going to finish at the point 4, 8. Now we know the formula for arc length, at least when they're written in this form, is the top one. I'll call the top one number 1, right? So we use equation to get the arc length. It's the integral from, don't know, square root of 1 plus the derivative of this guy, which is x squared, dx. So it's going to be the integral of 1 plus x squared dx. So here's the problem. I need to know start x and I need to know finish x, but they haven't told me it the way they typically tell you, right? You know, like that. But I should be able to figure it out. What is the start and finish x values if you start at this point and you finish at that point?
The x coordinates for those points.
Yeah. 2 and 4. Agreed? Right, now let's look at that integral. There's two ways to do it. If it was a test, do an x sub, please, so I can give you lots of points in case you screw up. But if it's a homework question, won't you go and look at the tables? And you're finished. Same question. Well, kind of the same question. You double check this, it's 2, 1. There we go, got it now. Okay, I did it in my head wrong, but this guy is that guy, right? Now, can you imagine the question was find the arc length of this function from here to here? Well, we would use number 2. So it'd be the integral from somewhere to somewhere. 1 plus the derivative of that. Now, that's a little bit messier. I would actually separate that out as the square root of 2 square root of y. That would allow me to call it that. So my g of y would be that. And so its derivative, which is what's going to go in here, would be 1/2 root 2 to the y to the negative half. And that would be root 2 over 2 square root of y. So you would go root 2 over 2 square root of y. Much uglier, but doable. That's 2, that's 4, so you get 2y, and you get that. What would the start and finish value be this time? Would it be 2 and 4, or would it be 2 and 8? Going
and
from
8.
this point to this point, but using y's.
2 and 8.
So if you've got 2 points and you're going from one point to the next, if it's x's, don't you get the start and finish from the x coordinates? But if it's in terms of the y, well, you get the start and finish of the y coordinates. I don't even want to go near that guy. I hope something in the tables would be the answer to that, because I'm pretty sure you couldn't do it any other way, easily at least. There might be a u sub in there that I can't think of, but I don't think so. Are we good? Right. So next thing I want to talk about is questions where they ask you to set up the integral but not to evaluate it. And these questions are 14. Let's check it as 14. 15 to 17. Did I do yesterday questions where you weren't asked to evaluate, you were only asked to set them up? Have we done one of those? Okay, so let me give you an example of what that might look like. Y equals 2 cosine x, and x is going to be from 0 to pi. And the question would say set up, but do not evaluate. So in this case, it would be L equal the integral from 0 to pi, the square root of 1 plus the derivative squared dx. Now, if you differentiate 2 cosine x's, don't you get negative 2 sine x's? Right, if you differentiate 2 cosines. I would just tidy it up a little bit, but not much. And that would be your answer. So in a lot of ways, aren't these questions very easy to do, because you really just do a couple of lines and you stop. So that is it set up, but not evaluated. If I had to evaluate this one, do you know, I suspect the question would be, give the answer to 2 decimal places, because won't the answer be, use your calculator. And since I've got this idea in front of me, I showed you how you can plug in Y1, zoom 0, and then start and finish. I want to show you another way of doing that same question. But this time we're going to do it, excuse me. My phone is beeping at me through my earphones because it's connected to it. And so I just had to switch it off so it won't bug me. So I've got a new way of doing it. So here we go. I'll do it slow, but you can always watch the video later. There's math. If you scroll down to number 9, function integral, you hit enter. You then type in whatever the ugly function is. I'm not going to type that one because it would take me too long and I'd probably screw up. So imagine it was square root of 1 plus x cubed. I don't know, add x squared. Right? So can you imagine that ugly square root, whatever it is? In this case, it would be what, 1 plus 4 sine squared? Actually, you just have to go 1 plus 4 bracket sine x close bracket squared, because that's how you get it in. Type in the guy you want, comma x, comma start at 0, comma finish at pi, close brackets. So if you don't want to go through that whole process that we showed you yesterday of typing in the Y1, sketching it, and then going into the other menu, can you see this is, it's very concise, right? It's in one place. Fingers crossed, I didn't screw up. Go. There's your answer. And to 2 decimal places, 9.54. You okay with that? You comfortable maybe using that instead of the other way if that's, you know, some people like it, some don't. So I thought, well, the heck, I'll show you both. Right. If we are cool, can we move on now to the last part of arc length? I should charge the college for all the paper I buy. I won't, but I should. And they will tell me, quite rightly, that I can have as much paper as I like. I just have to come by the office and pick it up. Do you know that's the equivalent of saying your wages are ready, but they're in the top of Mount Everest. You just need to climb up there to get them. Well, theoretically, my wages are waiting for me, but I don't really want to go to my office to get anything for lots of reasons. Right, so actually, my wife goes and gets me paper, if I'm being honest. So she works in the college as well. Okay, so who's left? Well, we have one more guy, which is a special function, and I'm trying to find some examples of it. And you're going to find these in question 12, 13. I think there's another one, but let me just check if there is or isn't. That's it, there are only 2 questions. And we're going to calculate what's called the arc length function. And the arc length function is s of x. So you'll know what it is because it's 12 and 13, but if I didn't tell you it was 12 and 13, it would say, find the arc length function s of x, and then it would tell you something. So I'll give you an idea of what it looks like. Imagine you've got a function called y equals f of x. And you start at this guy here, which I'm going to call A, and you travel to, say, this guy here. But I'm not going to make him a number. I'm going to make him x. Then the distance from A to some random x coordinate called x is what we mean by the arc length function. So it's basically, you're creating a formula, right, a function, that allows you to tell how far along the curve x is from a starting point A. So in these questions, you're going to be given a starting point. Oh, I'll make mine one up. Oh, no, I'm not. I've learnt my mistake. Don't make up your own. Use the books because they're nicer. Oh, God, that's not that nice. But here goes. So you're going to give a function. And you're going to be given a point. Let's say that point. And we're being asked to find that guy. Now, if I told you it went from 1, 2 to 4, 5, right? We could do it. So what you do is you just basically remember this thing. It goes from A to x, the square root of 1 plus the derivative function squared dt. And you think, where in heck did this dt come from? See this guy here? He's f of t. Do you know variables are sometimes called dummy variables because can't you write the same relationship with x, and then if you change all the x's to t's, isn't it essentially the same formula? It's just as a different variable label. So y equals 2x to the 3 halves and f of t equals 2x to 2t to the 3 halves are essentially mathematically equivalent. Right? Do you know why they make this in t's instead of x's, which is what you would expect?
Because x is what we're using in the integral.
Right, and it's bad math, isn't it, to have a variable that's then going to get replaced by itself? You know, it's not a good idea. Right. Well, that's going to be the integral then from 1 to x. So you see how a is the x coordinate, so that's 1. Square root of 1 plus the derivative squared. If you differentiate this guy, won't you get power rule? Multiply by the number and then reduce it by 1. And that gets me 4t to the half. Are you happy where that came from? Power rule. Multiply by 3 halves and reduce the power by 1. And you shouldn't be happy because I can't count. Are you happy now? Right. Which now becomes the square root of 1 plus 9t. And if you're wondering where that came from, isn't 3t to the half squared 3t to the half times another 3t to the half? And the 3's get you 9, and these two guys get you t. Okay, let's take this guy to the end. I better not do that. How am I going to integrate the square root of 1 plus 9t?
You could pull out the 9.
Yeah, you could. I'm not sure it would do much good in this case. In some cases, that would be a good idea. What method, what integration method could I use?
U sub?
Yeah. What U sub would work in this question?
1 plus 9t.
Okay. Now, if you differentiate that with respect to t, you get 9. And then the crossover, and then isolate the dt. Okay. So the integral of the square root of u times 1/9 du. That gets you u to the half. Let's stick the 9th out there. Power rule. Add 1 to the power, and then divide by the new power. I believe that gets me 2/27, the square root of u cubed. Won't that get me 2/27, the square root of 1 plus 9t cubed, evaluated at t equals a to t equals x, and it's not an a, it's a 1. T equals 1, t equals x. And what does that get me? It gets me 2/27, the square root of that guy cubed. Take away, well, if you plug in 1, you get 10. 10 cubed gets me 10 root 10. That gets me 20/27, 10 root 10. And that's just as ugly as the question I made up, so I guess even the book doesn't do a great job at making it nice. Are we okay with that process? It took a while, but we got an answer. For instance, see if I found S of 5, just for argument's sake. Wouldn't that be the distance from 1 to x being 5? And so this allows us to find lots and lots of different arc lengths without having to do the question from scratch each time. But you just do it once, and then you can do it from x equals 1 to x equals whatever you like. Right. This is going to move. Are we good? I got one nod. We good? Okay. Next. We need to look at our next section. I believe it's called 7.8. Improper integrals. There are two kinds. Today we're going to focus on the intro to type 1, but for completeness sake, I'm going to tell you type 2. A type 1 integral looks like this fella here. If one or other or both the limits are infinite, then it is a type 1 improper integral. Now you might think to yourself, you know, if you start at 1 and you go to infinity, right? So that's basically, you know, going to the right-hand side forever. Won't the area under these curves always be infinite? You would think logic would tell you that, but you're wrong. It is possible for these integrals to be a number, right? To be physically 4 or whatever, or at least its limit would be 4. And type 2 looks like this fella. What makes type 2 integrals improper? What's not right about them?
0 in the denominator.
So at x equals 3, isn't there a vertical asymptote, which means the curve shoots off to infinity? Would you agree trying to find the area under a curve with a vertical asymptote is probably a dangerous thing? If not difficult, definitely weird. So how do we actually do those? Well, we won't find out today because I'm going to show you the intro to the math that you will need so that when I see you on Monday that we can do it. And while I'm at that, because Wednesday is a holiday, one of the sections that we would have done won't be part of the test a week on Monday. I know it's a long time away, but give you a heads up. Once we finish this one, we'll then move on to doing surface integrals. And then after that, it was going to be applications of integration, but that won't be in the homework and it won't be in the test. That will get pushed forward to the following 2-week cycle. So just thought I'd tell you that. Now we may get it started, but I know we won't get it finished. So because I know I won't get it finished, it's not fair to, you just finish it off yourself and good luck. It doesn't seem right. So let's go back to how we're going to deal with this. Well, I'm going to bring back a guy that you probably thought you'd seen the last of. Limits. To find these integrals, we use limits, which means that we have to refresh ourselves on techniques that you can use to get the limits of expressions. I'll give you an example. And I'm going to use the letter T for all these because typically that's the go-to letter in the book. And actually all the books I've seen, for some reason, T gets the job, right? So let's look at the limit as T tends to infinity. The first technique I'm going to show you for finding limits is, at least I call it brute force. Really what you do is you do a calculation with infinities in it. And you can actually get away with it in certain circumstances, but not all circumstances. So if you replace T with infinity, you get infinity squared plus 5. Now, calculations with infinity are a little bit weird than normal multiplication with force kind of calculations. Isn't infinity squared still infinite? So that would essentially be 1 over infinity add 5. Isn't infinity add 5 still infinite? Which gives me infinity at 1 over infinity. But 1 over infinity does have a limit. It does have a number that it gets closer and closer to. That's all limits really tell you. What number is 1 over infinity?
0.
0. So the limit of this fraction would be 0. And that's called brute force, right? Where you replace the t by infinity and you do infinity calculations. Here's another one. Okay. The square root of t squared take away 5, but we're going to find its limit as t gets infinitely large. Well, according to the brute force method, we would go infinity squared take away 5. Well, let's do it all in one go. Isn't infinity squared still infinite? If you take 5 away from infinity, isn't it still infinite? So this is now the square root of infinite, right? What is the square root of infinity? What's the square root of an infinitely big number?
Infinity.
Yes. Now, we won't say as our answer to this integral, if that happens to be the calculation we use, we won't say the answer is infinity. What we will say instead is that the integral is divergent. Now, we like the word divergent. It kind of covers all possibilities. And the reason why I want to say it covers all possibilities is because there are some situations where the integral doesn't exist either. To me, in a way, infinite doesn't exist, right? It's infinitely big. You can't really tell how big it is because it's infinitely big. Now, if you try a brute force on sine t, you get that. What is that? Or tell me what that means, or tell me what you can conclude from that, because it's a bit of a cheat. What's the sign of an infinitely large number?
Is it not defined?
Good, I like that. Would you agree that as the sine function travels to the end of the universe, doesn't it still go up to 1 and down to -1, and there is not one honed in single value that it becomes? So does not exist is not what we write, but you're correct. We write divergent. So can you see how divergent doesn't always mean the answer is infinity? Can't divergent also mean that it doesn't exist? So think of divergent as, if it ain't a number, it's divergent, right? If it ain't 42, right? If that answer isn't 42, it's divergent. Okay, still on brute force. Here are two, oops, darn it. So used to doing X's, it's hard to stop. Very similar, but not the same. Tell me, using brute force, what the answer to each of these questions is. Okay, what's the answer then to e to the power of infinity?
Infinity.
Which we will call divergent, right? What about e to the power of negative infinity? And don't jump in, think a few seconds before you commit yourself. E to the power of negative infinity.
Zero.
Convince me, it is 0. Convince me how you figured that out.
The negative exponent means that it brings the e to the bottom fraction under 1. And that's the same situation as before.
That makes sense? So negative and plus infinity do not behave the same way with some functions, agreed? So you have to, take each one on its own merits and figure out in brute force, right, what would happen. Are we good? No. That was brute force. Can be used in a lot of cases. Actually, if it can be used, that's probably the guy I go to first. If I look at a question and say, yep, I could probably get the answer to that using brute force, I would do it, right? But that ain't going to be the case, every single time. So there are 2 other techniques. L'Hopital or L'Hospital. And I don't know what the name of this is, so I'll tell you what you do. Can't think of a name for it, so I'll tell you what you do. You divide the top and bottom by the same power of t, right? We're using t's for every question. Can you remember what L'Hopital said you did? Get the cobwebs out. What's the L'Hopital's law or rule? Anybody? While you're thinking about it, let's set up a question. If I was going to do L'Hopital's rule on this particular limit, you would write down equals and put a little L above it so everybody knows you're using L'Hopital. And it would turn into a different limit that typically gets you either the answer or closer to the answer. What do you do to the top and what do you do to the bottom in L'Hopital's method? I'm trying desperately not to tell you, because if it kicks in, you'll remember it more than if I tell you and then you'll forget it again. Last chance. You differentiate the top and bottom separately. So you differentiate the top and you get 8t plus 1. You differentiate the bottom and you get 6t. Now you might say, why don't I just do brute force? Can you trust me, if you put infinity here and infinity here, don't you just end up with infinity over infinity? And no, infinity over infinity is not 1. Unfortunately, that's not how infinity works, right? Some calculations just don't work, right? Does it ring bells now? Differentiate the top, differentiate the bottom, right? Numerator, denominator. Now, if I plug in infinity here, it's still no good. It's called the indeterminate form when it looks like that. So all I do is I do L'Hopital again. And in this case, there's the answer. Side issue. I don't like saying things, sometimes I can't avoid it, but I don't like saying things if I just say, trust me. Let's tell you why that can't be 1. Can you imagine that top infinite is the number of fractions in the world? And that bottom infinite is the number of whole numbers in the world. Would you agree that there's an infinite number of fractions and that there's an infinite number of whole numbers? So if I took all the fractions and put them on the top and all the whole numbers and put in the bottom, right, that would be the equivalent of this calculation. If you look at the whole numbers 1 and 2, between the number 1 and the number 2, we'll do 0. From 0 to 1, right? From the number 0 to the number 1. How many fractions are between 0 and 1?
Infinite.
Yeah, 1/2, 1/3, 1/4, 1/5, 1/29th, 1/2 billionth, and 3. Infinite. Now, doesn't that mean then that there's an infinitely more fractions in the world than there are whole numbers in the world? What I'm trying to get across is, can't you have 2 different kinds of infinity where one infinity is bigger than the other? They're both infinite, but isn't there a lot more fractions than there are whole numbers? Yeah, I tried my best. That's the best explanation I can give you for why the answer is not 1. Now, I promised you 2 methods, so let's return to this question and talk about the second method, which was, because I can't remember if it even has a name, but I doubt it does, divide the top and bottom by the same power. So let's look at this question and look at how we would do it. Would you agree the top power on the numerator is t squared, right? The biggest power on the top is t squared, and on the bottom it's t squared. So if they're both the same, you divide the top and bottom by t squared. Now that means this integral now becomes the limit as t tends to infinity of 4 plus 1 over t, and 3 take away 5 over t. And then you do brute force. 4 plus 1 over infinity, 3 take away 5 over infinity. But isn't 1 over infinity and 5 over infinity both zeros? So 4 add 0, 3 take away 0. There's your answer. 4/3. Now, as long as it's a polynomial on the top and a polynomial on the bottom, as we have here, then the divide top and bottom by the same power of t does a really good job at getting you the answer with the least amount of work. If you did L'Hopital, can you imagine sometimes you might have to do L'Hopital 4 or 5 or 6 times before you'd get to the place where you'd get the answer? So I'm going to show you an example of a question that I wouldn't do with L'Hopital, but I would do with this method. So the limit as t tends to infinity of 4t to the 10 plus 6t to the 9 minus 11 over 2t to the 10 plus 6t to the 8 plus 1. Can you trust me that if you had to do L'Hopital with that, do you know you'd have to do L'Hopital probably about 8 or 9 times, one after the other, before you could get to the point where you actually knew what the right answer was? On the other hand, the highest power in the top is 10, the highest power in the bottom is 10. So I'm going to divide everybody in the top with t to the 10 and everybody in the bottom with t to the 10. So the limit becomes this guy. You get a 4, you get a 6 over t, and negative 11 over t to the 10. Are you happy about what these become when you divide them by t to the 10? And on the bottom, you get 2, 6 over t squared plus 1 over t to the 10. So far, so good? Now, when you do the brute force, won't that get you 0? 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 So all you're going to be left with is 4 over 2, which is 2. The brute force can also be used when the powers on the top and bottom are not the same. You have to put little brackets for emphasis. You have to make a decision. You must use the same power of t on the top that you use on the bottom. Otherwise, the question doesn't work. The reason why this works is, won't that just generate a new fraction that's the same as the old one, that just looks different? Now, t cubed, t to the 4. Got a decision to make. I can only pick one power. Do you pick t cubed or do you pick t4? So here's the rule. Pick the small one. Pick t cubed. Both guys need to be divided by the same amount. If you have a choice, pick the smaller of the two. Let's see what that looks like. That guy gets you 3. That's this fella. And that gets you that guy. That's the top line, right? What would you get if you take this guy and divide him by t cubed? What would 2t to the 4 divided by t cubed become? Two t to the 4 divided by t cubed. What would that simplify down to?
2t.
There. And wouldn't the other one become eventually 1 over t squared, right? So that's how we do it. Now let's do brute force. I should probably put this line in. So it's going to equal, I'll make it red, 3. 2 over infinity. Won't 2 over infinity get you 0? Take away. Won't 1 over infinity cubed just get you take away 0 as well? What will 2t get you if you make t infinite? What's 2 lots of infinity? Another way of saying that.
Infinity.
Now, isn't 1 over infinity squared 0? So we're going to have 3 left in the top and infinity on the bottom. Now, what does 3 over infinity get you? Brute force, 3 over infinity.
0.
0. Now, I know I only have 2 minutes, so you're getting a really quick version of the last situation. The limit is t tends to infinity of t to the 5 plus 5 over t cubed plus t. Now, in this case, you've got a choice, right? T to the 5 or t cubed? What do you divide them by? T to the 5 or t cubed?
T cubed.
Cubed.
Smaller of the two, right? Now that becomes t squared, 5 over t cubed, 1 over t squared. All right, let's do brute force. Infinity squared is infinite. 5 over infinity squared is 0. That's the top. 1 is still 1. 1 over infinity squared is 0. Infinity over 1. Isn't that answer infinity? Which we will call divergent. Okay, has that kind of refreshed your Calc 1 limit stuff, at least in some degree, right? So when we come back on Monday, we're going to do some more of these guys. I've changed. I know I gave it the. Let's rewind that sentence. I went and asked you for some nicknames. I've decided not to do that because only 4 of you wanted it, and it's actually more work now rather than less. But I believe I figured out how to get round the hiccup in the mail merge. Everybody here got an email with their grade, probably more than once while I was playing about with it. Is that correct? Now, anybody who's not got it, I tried to find a different email to use because I finally figured out what I believe was the problem. Some of your student OC emails aren't working right for me. Now, it may be that you should be Kathy Owen with a 2 in the middle, right, or whatever. But I ain't getting to you, and that's why you're not seeing it, right? So I'm picking Kathy. I don't know if Kathy was one of the issues, but whatever. So if you're still not getting it from that last batch, what you need to do is shoot me an email saying, can you use this and give me another email that you would use? And I will replace that by your OC email. And that way I can send you out anytime you want, essentially, what your up-to-date grade is as far as I'm concerned. So that looks to me the way to do it.
I think my confusion was whether the email was coming through Canvas or my student email, and it came to my student email.
So you got it now?
I believe so, yes.
Right. So you probably weren't one of the people I changed the emails to, but I can't remember. You may want to, if you gave a personal email, because sometimes when you log on to the school, you give 2 emails. You give the college email and my personal email. You may want to go and look at your personal email, and if you find that I sent it to that, then that's the email I'm now using. So whatever. You'll get it in one of 2 places. That's bottom line. Have a nice weekend, everybody. I will see you tomorrow. We only really know enough to finish doing arc length. I really haven't covered anything on the next section, so you won't be able to do the homework yet.
You'll see us tomorrow?
I'll see you on Monday.
Monday.
If I see you tomorrow, one of us is in the wrong place.
Big fact.
Okay. Bye-bye, guys.
Remember to say hi.
Oh, shit. Say
Most-
hi, quick.
Most people did.
They
So-
did. Okay, we're good. You have a question, Sam?
Yes, so
Okay.
office hours that we scheduled at
You just
12.
want to do them right now.
Okay.
Perfect. So who's causing you issues?
Okay, so I was hoping we could look and talk over my test, if that's
Sure.
okay. So let me grab my notes. Okay. So the first one that I got wrong was number 3.
Okay, what was the integral?
The integral was from 0 to pi of e to the power of cosine t times sine of 2t. And this
does
one, I may,
Does it look like that?
I can't see your screen.
Let me do it. Look like that?
Yes.
Did you recognize that the sine of 2t has to be rewritten as 2 sine t cosine t?
Yes, I did.
Okay, so it's a u sub then, isn't it?
Mhm.
And the u sub would be who?
U of cosine, but before we get too far,
Yeah.
I think I may have written the actual answer in my work because I realized I had forgotten a negative. So I was hoping that we could just check that answer and see if that's the right one. That way we wouldn't have to go through all the work to find out.
Sounds like a plan, right? So I'm just going to have to stop this and go out and bring up the test. Let's see, what section am I doing? 1, 2, 3, 4. Here we go. And let's do scores. Oh God, excuse me. Oh, what have we got here? Here we go. And number 3. And the correct answer is just positive 4 over e, not negative 4 over e. So it sounds like you fixed it.
Yeah.
Okay, let's move on then. What's the next one?
The next one, if you look real quick, is number 7. So let me look at, actually, integrals right here. So
I will, yeah, by the way, this is not going to get on the video, right? So
yeah.
this will get deleted.
Yeah.
Okay, so we're on 7.
So number 7 is the integral from 0 to a.
Yeah, I've got that in front of me. I hope it's 9x squared, but the one I've got may change because everybody gets a different one.
Okay.
Do you have a 9x squared or some other number?
I have a 9x squared.
Okay, so you've got that one. Do you recognize this one as a x sub?
Yes.
Excuse me. What would be the appropriate x sub in this situation then?
The situation is a sine of theta.
Great. So dx by
Then,
d
not
theta.
able to see your work.
So a cosine theta d theta, right? So we're looking at an integral of 9 times 9 sine thetas all squared times the square root of a squared, take away 80, I'm calling it
I'm not
a,
able to
it's
see.
not 9, it's an a, darn it, my a's look like 9s. Take away a squared sine squared theta, and the dx becomes a cosine theta d theta. Does that look good?
I'm not able to see your screen.
Oh, we're back to that, aren't we? Okay. Right.
So let me peek real quick.
That guy, this piece. Do we have those pieces? 9 of this guy squared, the square root of a squared, take away this guy squared, times dx, which is this piece here. Do you have all those pieces? Because if you don't, that's pretty much where you went wrong.
Dx. Oh, so yeah, so instead of a cosine theta, it was 1 over a cosine theta that I did, and that was the mistake I made.
Yeah.
Okay,
Okay.
cool.
Okay, next one.
Is number 8.
I have it in front of me, so I'll just write it down. You tell me if it looks good.
Mhm.
It's an x squared take away 49
Yes.
and it's over an x cubed and has a dx.
Mhm.
And again, it's an x sub.
And I used 7 secant theta.
Looks good. So dx will be 7 secant tan theta d theta. Did you do the 1 over thing again?
Yeah, so it looks like that might be, yeah, that's issue I'll need to look out for. So that's where I got it wrong.
Okay. Well, easy fix.
Yeah. Then,
Where are we off to next? Are we getting close to have done?
yes, only 2 more.
2 more.
Cool.
Okay, what's the next one?
So 9.
Okay. So we have an integral. I have y over y plus 4
Yes.
and a y take, a 2y take away 1 and a dy.
Yep.
Okay, so if we do the partial fraction, we have this fella with this guy, and it's going to be an a over y plus 4 and a b over 2y take away 1. Agreed?
Yes.
And both are a's, and there isn't any ay plus b's going on. This guy is missing a 2y minus 1 top and bottom. And this guy is missing a y plus 4
Yep.
top and bottom. So now I can just match the top row. So the top row says y will equal a lots of 2y take away 1 plus b y add 4. Looking good?
Yep.
At this point here, don't we do the choose thing?
Yes.
So give me what value of y you want to choose first. Doesn't matter in this case because both, any order will work. So
I used -4.
good choice, which makes this fella -4. A times 2 lots of -4 take away 1 is -9 plus 0, which makes A positive 4/9.
That's what I got.
Maybe it's here then. Who are you going to choose now?
Positive 4/9. So I used 1/2.
Good choice. Right one. So 1/2 equals, that ends up being 0.
Mhm.
And B, 1/2 plus 4 is 4.5. So I'm just going to call it 9/2. And when you do a little divide and so on, I believe you get B as 1/9.
That's what I got.
So that's not the mistake. So we're getting close.
Wait. So 1/2. Oh wait, it's divided by. Okay, that makes sense. Never mind.
Good.
Yep.
Did you get 1/9?
Yes, I did.
Right, so we'll continue then. So you have a y over y plus 4, 2y take away 1 dy. And we now know it splits out as a 4/9 of this guy plus a 1/9 of the other guy dy.
Yep.
This guy gets you 4/9 the natural log of y add 4. Right?
Yep.
This guy here, I can do the linear shortcut or I could do a u sub. But what you get is 1/9 the natural log of 2y minus 1, and you get a half. And the half comes from that 2, generates an extra half. Now, if you do it by your u sub, you'll get the same result. Did you get 1/18?
Yes, I did.
So that ain't the problem. So I'm not sure what the problem is, except I must have done the same mistake as you. So I'm going to look at the answer. And the only mistake you made was a 1 point not given absolute values.
Oh.
And I gave you that point, so you never lost it.
Okay. Cool.
because I told people don't worry about absolute values. You know, as long as y is positive, it's going to be fine anyway, right?
Yeah. Okay.
Okay. So you never lost anything, even though WebAssign said it was wrong.
Yeah.
It was very superficial wrong. Okay, what else? We got one last one, I think.
Yes. So number 10.
Oh, last question. So we're looking at the integral of 10. Tell me your answer in case it's just an absolute value thing.
It is the ln of the absolute value of x minus 1,
Check.
and then minus ln absolute value of x.
Okay, so it's not right. So let's figure out what the issue was. Okay. So I'll take the original and break it into its baby fractions. And that's going to be a over x minus 1. And who shall I put above x squared plus 9?
bx plus c.
Okay, so that's not where you went wrong. The first fraction is missing an x squared plus 9. And the second fraction is missing an x minus 1. Agreed?
Yes.
So the top row is 10, is a lots of x squared plus 9 plus bx add c x minus 1. And now it's time to start choosing.
So I used 1.
Good choice. So you get 10 equals a lots of 10 plus a whole load of nothing. So a is 1.
Yep.
So that now means 10 is equal to x squared plus 9 plus bx add c x minus 1. It's always a good idea, the minute you know what a letter is, to give it a number, right?
Yep.
To replace it by its value. Okay, who are we going to choose now?
0.
Very common, very correct. So 10 is going to be nothing squared add 9, so I'll call it nothing add 9, plus nothing add c, which is c, and nothing take away 1 is negative 1. So I got that, which gives me, I believe, c is negative 1.
Yep.
Okay. Which means we now have, whoops, keep my eye on things, there we go. We now have 10 is equal to x squared plus 9 plus bx take away 1 x minus 1. So who do we choose for the last one?
I chose 2.
Why not? So 10, 4 add 9, add 2b take away 1 times 1. That's 13, so you get negative 3 is 2b take away 1. That's what, negative 2 gets you 2b. I get b is negative 1. How's that look?
I got b equals negative 2. Let me look.
Let me check. It could be me. It could be me. Nope.
Okay. 4, 1 minus that 12. Okay, let's see. So 4 and 9 become a 13 plus 2b
Minus 1.
minus 1. 13 minus 1 is 12. 10 minus 12 should be negative 2 divided by 2. Okay, yeah.
Looks like we found it.
Yes.
Okay.
So that 1 b equals negative 1. Okay. Awesome. Thank you very much.
You are welcome. Have a nice weekend.
You as well. Bye.
Bye.